Hello, in this lecture we will find the diameter of the semicircle. In the drawing we have a semicircle and we know that AB is the diameter of this semicircle, and we also know that AD equals to 7 units, DC equals to 15 units, and CB also equals to 15 units, and we want to find out the size of AB, that is the diameter of this semicircle. So first of all we will make a construction. We will connect together points D and B by a straight line. So actually angle ADB equals to 90 degrees according to rule number 1, that states that peripheral angle resting on the diameter of the circle equals to 90 degrees. Okay, peripheral angle resting on the diameter of the circle. It can be circle or semicircle of the circle equals to 90 degrees. So I will read rule number 1 again. Rule number 1 states that peripheral angle resting on the diameter of the circle equals to 90 degrees. So actually angle ADB rests on AB, that is the diameter of the semicircle. Therefore, according to rule number 1, angle ADB equals to 90 degrees. Okay, so angle ADB rests on AB, that is the diameter of the semicircle, therefore it equals to 90 degrees according to rule number 1. To 90 degrees according to rule number 1. So I we'll read the things that I wrote again. The peripheral angle ADB rests on BA, and BA is the diameter of this semicircle. Therefore, according to rule number 1, it equals to 90 degrees, because rule number 1 states that peripheral angle resting on the diameter of the circle equals to 90 degrees, and peripheral angle ADB rests on the diameter of this semicircle, therefore it equals to 90 degrees. So this angle ADB equals to 90 degrees. Okay, so in the next step we will define the center of this semicircle as point O. Again, point O is the center of this semicircle, and then we will join together points O and C by a straight line. And we will also join together points O and D by a straight line. And then we will focus on the green triangle ODC. And we will also focus on the orange triangle OBC. Again, we will focus on the green and the orange triangles. Triangle OCD is the green triangle, and triangle OCB is the orange triangle. So actually on those two triangles, we know that DC equals to CB equals to 15 units. So side DC of the green triangle equals to side CB of the orange triangle. Both of those two sides are equal to 15 units. So I'll write it down. Side DC of the green triangle equals to side CB of the orange triangle. So both those two sides are equal to 15 units. Okay, so again, side DC of the green triangle equals to side BC of the orange triangle. Both those two sides are equal to 15 units in size. And also we know that OB is the radius of this semicircle, because it starts from point O, that is the center of this semicircle, and ends at point B, that is a point on the circle, or on the semicircle itself. For that reason, OB is the radius of this semicircle, I will mark it as R, abbreviation for radius, and OD is also the radius of this semicircle, because it starts from the center of the semicircle and ends at point D, that is a point on the circle itself. Therefore, OD is also the radius of this semicircle. I will mark it as R. Okay, so OD, side OD of the green triangle equals to side OB of the orange triangle. Both of those two sides are equal to the radius of the semicircle, so OD equals to OB. Both of those two sides are equal to the radiuses, to the radius of the semicircle. Okay, they are equal to each other because they are radiuses of this semicircle. Okay, OD equals to OB because of the fact that both those two sides are the radiuses of this semicircle, and OC equals to OC. OC is a common side, that is to say, it belongs to the green triangle, and OC belongs also to the orange triangle, so OC equals to OC, so it is a common side. So actually we proved that three sides of the green triangle are equal to three sides of the orange triangle. Therefore, the green triangle is congruent to the orange triangle. The green triangle ODC, is congruent to the orange triangle OCB. So I'll repeat again. The green triangle ODC is congruent to the orange triangle OCB, because we found that three sides of the green triangle are equal to three sides, or all the sides of the orange triangle. Therefore, those two triangles are congruent to each other. Okay, according to the rule of side, side, side. According to SSS rule. Okay, according to side, side, side rule. If you prove that all the sides of one triangle are equal to all the sides of another triangle, then those two triangles are congruent to each other. We proved that all the sides of the green triangle are equal to all the sides of the orange triangle. Therefore, those two triangles congruent to each other. Okay, so therefore we can also deduce from the fact that those two triangles congruent to each other that angle OCD equals to angle OCB. Again, angle OCD equals to angle OCB. those two angles are equal to each other. According to the rule that corresponding angles in congruent triangles are equal to each other. Okay, so angle OCD equals to angle OCB, and if we define angle OCD as alpha, then angle OCB that equals to angle OCD will be also equal to alpha. Okay, angle OCB equals to angle OCD equals to angle OCD. Both those two angles are defined as alpha. Okay. So in the next step, we'll focus on triangle CDB, and first of all we will define this point as point E. This point is defined as point E, and we'll focus on triangle DCB. This triangle DCB. So in triangle DCB, side DC of triangle DCB equals to side BC, because those two sides are both equal to 15 units. Okay, DC equals to CB, both those two sides are equal to 15 units. Okay, in triangle DCB, side DC of triangle DCB equals to side CB of triangle DCB, both those two sides are equal to 15 units. And we have a rule, I will call it rule number 2. Rule number 2 states that in front of equal sides in the triangle there are equal angles. So I'll write it down. Rule number 2 states that in front of equal sides in the triangle there are equal angles. I will read rule number 2 again. Rule number 2 states that in front of equal sides in the triangle there are equal angles. So actually in triangle DBC we know that DC equals to CB. Both of those two sides in triangle DCB equals to 15 units. Therefore, according to rule number 2, we have in front of this side, side BC, we have angle EDC, and in front of this side DC, we have angle EBC, this angle. So according to rule number 2, those two angles that are located in front of equal sides are also equal between them. That is to say, according to rule number 2, in triangle DCB, angle ECB, angle EDC, this angle equals to angle EBC, to this angle EBC, that is according to rule number 2. Okay, again, in triangle DCB, angle EDC equals to angle EBC according to rule number 2. According to rule number 2, those two angles are equal to each other because of the fact that they are located in front of equal sides. Therefore, they are also equal between them, equal to each other. Okay? So, and if we define angle EDC as theta, then this angle that equals to angle EDC also will be equal to theta. Okay, so actually those two angles are both equal to theta. Okay, angle EDC equals to angle EBC, and both those two angles are equal to theta according to our definition. So in the next step, we will focus on triangles DEC and triangle BEC. On the green triangle, triangle DEC, and on the orange triangle, triangle BEC. So in triangles DEC and triangle ECB, so we will focus on those two triangles. On those two triangles, side DC of the green triangle equals to side CB of the orange triangle. DC of the green triangle, side DC of the green triangle equals to side CB of the orange triangle. Both of those two sides are equal to 15 units. Okay, so we have side DC that on the green triangle equals to side CB of the orange triangle. Both of those two sides are equal to 15 units. And actually side OC is a common side. Side EC is a common side. Side EC is a common side of it. It belongs to the green triangle, triangle ECD, and side EC also belongs to the orange triangle, triangle ECB. So EC equals to EC. It is a common side. It belongs to both triangles, triangle DC and triangle ECB. Common side. Okay, so side DC of the green triangle equals to side CB of the orange triangle, and EC equals to EC, it is a common side. And we also know that those two angles are equal to each other. So actually angle DCE of the green triangle, angle DEC of the green triangle, this angle equals to angle ECB, of the orange triangle. So both those two angles are equal to alpha. Okay, so again, side DEC of the green triangle equals to side ECB of the orange triangle, and both of those two angles are equal to alpha. Okay, so we actually proved that two sides of the green triangle and the angle between them are equal to two sides of the orange triangle, and the angle between those two sides are also equal in both triangles. So actually we proved that the green triangle, triangle EDC, is congruent to the orange triangle, triangle EBC. Okay, so triangle DEC, the green triangle, triangle DEC, is congruent to the orange triangle, triangle ECB. Again, the orange triangle DEC is congruent to the green triangle, triangle DEC is congruent to the orange triangle, triangle ECB, according to side angle side rule. According to side angle side rule. Okay, again, triangle, the green triangle, triangle DEC is congruent to the orange triangle, to triangle ECB, according to side angle side rule. Actually, side angle side rule states that if two sides and the angle included in one triangle are equal to two sides and the angle included of the other triangle, then those two triangles are congruent to each other according to side angle side rule. And the angle included is actually the angle that is between those two sides. Okay, so if the two sides and the angle between those two sides are equal to the two sides and the angle between the two sides of the other triangle, then those two triangles are congruent to each other according to side angle side rule. Okay, so those two triangles are congruent to each other, therefore DE equals to EB. Side DE of the green triangle equals to side EB of the orange triangle, according to the rule that, okay, DE equals to EB, according to the rule that corresponding sides in congruent triangles are equal to each other. And also angle DEC, this angle equals to angle CEB, this angle. So angle DEC in the green triangle equals to angle BEC in the orange triangle. Okay, again, angle DEC in the green triangle is equal to angle BEC in the orange triangle, according to the rule that corresponding angles in congruent triangles are equal to each other. Okay, so these two angles are equal to each other, and if we define one angle as x, then the other angle also will be equal to x. So we'll write that angle DEC equals to x, and also therefore angle BEC will be also equal to x. Okay, so actually we know that BD is a straight line because it is actually one of the sides of the right angle ADB. Again, BD is a straight line. Okay, BD is a straight line, or DB is a straight line, DB is a straight line. Actually, we made the construction, we draw a straight line between points D and B. Okay, so DB is a straight line. Therefore, if we focus on point E, the sum of the angles in the upper side of a straight line equals to 180 degrees. So angle DEB will be equal to 180 degrees from one side. Because of the fact that DB is a straight line, then angle DEB will be equal to 180 degrees from one side. Okay, angle DEB equals to 180 degrees from one side. Again, angle DEB equals to 180 degrees from one side because of the fact that DB is a straight line. Therefore, if we focus on point E, the sum of the angles in the upper side of point E along the straight line DB equals to 180 degrees. So if we focus on point E, the sum of the angles in the upper side of point E must be equal to 180 degrees. Therefore, angle DEB equals to 180 degrees. This is from one side. But what is the size of angle DEB? According to our definition, the size of angle DEB equals to x plus x. This is angle DEB, and the sum of the angles on angle DEB actually equals to x plus x. It is angle DEB equals to angle DEC plus angle BEC. Okay, angle DEB equals to angle DEC equals to angle DEC angle DEB equals to angle DEC plus angle BEC. plus angle BEC. Okay, so we found out that angle DB equals to 180 degrees because it is located on the straight line DB, and the sum of the angles at a certain point in the upper side of the straight line equals to 180 degrees from one side, but actually angle DB from the other side equals to angle DC plus angle BEC. But what is the value of angle DEC? Angle DEC equals to x degrees according to our definition. So we will substitute DEC by x, and angle BEC also equals to x degrees according to our definition. Okay, so in total we got that angle DEB equals to 180 degrees, angle DEB equals to 180 degrees from one side, but from the other side angle DEB equals to x plus x, that is 2x. Angle DEB from the other side equals to 2x. Okay, so from this equality we can deduce that 2x equals to 180 degrees. Okay, 2x equals to 180 degrees. 2x equals to 180 degrees. We derive it from this equality. Okay, so 2x equals to 180 degrees, and if we divide this equality by 2, we will get that x equals to 90 degrees, angle x equals to 90 degrees, x equals to 90 degrees. So actually this is angle x, so we can substitute x by 90 degrees here. So this is a right angle, it equals to 90 degrees, and this angle that equals to x is also equals to 90 degrees because we found out that x equals to 90 degrees. X equals to 90 degrees. Therefore we can substitute x, angle BEC, that equals to x. It is actually a right angle, it equals to 90 degrees. So we found out that those two angles are right angles. Angle CED is a right angle, and angle BEC is also a right angle. But we know that OC is the radius of the semicircle because of the fact that it starts from the center of the circle and ends at point C, that is a point on the circle itself. So therefore OC is the radius of the circle. OC is the radius of the circle. OC is the radius of the circle. Of the semicircle. Okay, OC is the radius of the semicircle, and therefore it is a straight line. Therefore OC is a straight line. OC is a straight line because it is the radius of the circle. It's a straight line. And again, we know that the sum of the angles at a certain point along the sum of the angles at a certain point along a straight line equals to 180 degrees. So if we focus on point E, on the left side, the sum of the angles will be equal to 180 degrees. Again, if we focus on point E on the left side only, the sum of the angles at point E on the left side will be equal to 180 degrees. So we can write down that angle CEB, this angle that equals to 90 degrees, angle CEB that equals to 90 degrees, plus angle OEB, this angle must be equal to 180 degrees because of the fact that along a straight line at one side, if we focus on point E, the sum of the angles is equal to 180 degrees. Again, angle CEB that equals to 90 degrees plus angle DEB must be equal to 180 degrees because of the fact that if we focus on only one side, on the left side of the straight line OB, at a certain point, that is to say at point E, the sum of its angles must be equal to 180 degrees. So angle CEB that equals to 90 degrees plus angle DEB must be equal to 180 degrees. This angle that equals to 90 degrees plus this angle must be equal to 180 degrees. So here we can subtract 90 degrees from this equality. We subtract 90 degrees from this equality and we will get that the value of angle DEB, equals to 180 degrees minus 90 degrees, that is actually 90 degrees. Okay, so we found out that this angle is a right angle, that is to say it equals to 90 degrees. Okay, angle DEB, this angle equals to 90 degrees. And we have a rule that states that around a certain point the sum of the angles is always equals to 180 degrees. So around point E, the sum of the angles is equals to 180 degrees. So I write it down. Around point E, this point E, the sum of the angles is equal to 360 degrees. Again, around point E, the sum of the angles is equal to 360 degrees. Okay, So actually at point E, around point E, we have three angles that are right angles. This is a right angle, this is a right angle, and this is also a right angle. So the total and the sum of the total angles, three angles that we have here, is 90 degrees times 3 is 270 degrees. Okay, so the fourth angle must be equal to 90 degrees in order to complete the sum of the angles around point E to 360 degrees, because 270 degrees plus 90 degrees will be equal to 360 degrees. Therefore, the fourth angle, angle OED, also must be equal to 90 degrees in order to complete the sum of the angles around point E to 360 degrees, because 270 degrees plus the size of the fourth angle will be equal to 360 degrees. So the fourth angle must be equal to 90 degrees, because 270 degrees plus 90 degrees equals to 360 degrees. So angle, so this angle is also a right angle. Okay? Or I can write down that 270 degrees plus the size of the fourth angle must be equal to 360 degrees, because of the fact that the sum of the angles around point E must be equal to 360 degrees. So here the fourth angle must be equal to 90 degrees in order to complete the sum of the four angles to 360 degrees. So the fourth angle must be equal to 90 degrees, and then we will get that the sum of the angles around point E equals to the three right angles, that is 270 degrees, plus the size of the fourth angle, that is also 90 degrees, then it will be equal to 360 degrees. So therefore angle OED equals to also 90 degrees. Angle OED equals to 90 degrees. Okay, angle OED equals to 90 degrees. And we actually found out that all the four angles around point E are right angles. All the four angles are equal to 90 degrees in their sizes. Okay? So in the next step we will focus on two triangles, triangle ADB and triangle OEB. Actually I will draw them again. Okay, we have the big triangle, triangle ADB. So actually I drew triangles ADB and triangle OCB and triangle EOB again. This is the small triangle EOB, and this is the big triangle ADB. So we'll focus on those two triangles. In triangles ADB and triangle EOB, okay, again in triangles ADB and triangle EOB, this triangle, actually we know that this is a right angle. Angle OEB is a right angle, as you can see from the drawing. Angle OEB, this angle is a right angle. So actually we have angle ADB in the big triangle equals to angle OEB in the small triangle. Both of those two angles are equal to 90 degrees. So I write it down. Angle ADB in triangle ADB equals to angle OEB in the small triangle OEB. Both of those two angles are equal to 90 degrees. Okay, and we also have angle B, that is a common angle. Angle B belongs to the small triangle EOB, and angle B also belongs to the big triangle ADB. Okay, so angle B is a common angle. So angle B equals to angle B. Angle B equals to angle B. A common angle, it belongs to both triangles. Common angle and actually angle DBA also must be equal to angle BOE or EOB. Okay, those two angles must be equal to each other according to the third angle theorem. So first of all, I will write down that angle BAB, this angle DAB, this angle in the big triangle must be equal to angle EOB in the small triangle. Angle EOB in the small triangle. So those two angles are equal to each other according to the third angle theorem. Third angle theorem. Okay, so those two angles are equal to each other according to third angle theorem. The third angle theorem states that if you have triangle, the two angles of that triangle are equal to two angles of another triangle, or if two angles of one triangle are equal to two angles of another triangle, then the third pair of angles are also equal in both triangles. Okay? If you have triangle that has two angles that are equal to two angles of another triangle, then the third angle or the third pair of angles are also must equal to each other according to the third angle theorem, because it is actually a complementary angle that completes the sum of the angles to 180 degrees, because the sum of the angles in any triangle is equal to 180 degrees. Okay? So actually, if we have two triangles, and two angles of this triangle are equal to two angles of this triangle, for example, this angle is alpha and this angle is also alpha, this angle is beta, and this angle is also beta. Okay, we have here two triangles that have two angles that are equal to each other. This angle in this triangle equals to this angle in this triangle, and this angle in this triangle is equal to this angle in the other triangle. Then what is the size of the third angle in this triangle? The size of the third angle in this triangle, we know that the sum of the angles in any triangle equals to 180 degrees. Therefore, the third angle in this triangle must be equal to 180 degrees minus alpha plus beta. Okay, that is the size of this angle, the third angle, according to the rule that the sum of the angles in any triangle equals to 180 degrees. So the sum of the angles in this triangle is equals to 180 degrees. Therefore, this angle plus alpha plus beta equals to 180 degrees. So the size of this angle will be equal to 180 degrees minus those two angles. Therefore, it equals to 180 degrees minus alpha plus beta. And what is the size of this angle in this triangle? It will be equal also to 180 degrees minus alpha plus beta. Okay? In this way, we proved that if we have two triangles that has two equal angles, then the third angle must be also equal to each other. The third angle of those two triangles are also equal to each other. Okay? So, according to the third angle theorem, angle DAB of the big triangle equals to angle EOB of the small triangle, and therefore we actually proved that three angles of the big triangle, triangle ADB, equals to three angles of the small triangle, triangle OEB. We have three angles that are in one triangle that are equal to 3 angles of the other triangle, 1, 2, and 3. Okay, all the angles in the big triangle are equal to all the angles in the small triangle. Therefore, those two triangles, triangle ADB is similar to triangle EOB according to angle similarity. Okay, therefore, triangle ADB, the big triangle ADB, is similar to the small triangle, is similar to triangle OEB. OEB according to angle rule. Okay, so I'll read again. Therefore, the big triangle, triangle ADB is similar to triangle OEB. OEB according to angle rule. If you prove that one triangle has 3 angles that are equal to other triangle, then those two triangles are similar to each other according to angle rule. Therefore, from the fact that those two triangles are similar to each other, we can deduce that the following relationship exists between their sides. Okay, therefore, the following relationship exists between the sides of those two similar triangles. Actually, AO over AB equals to OE over AD. Okay, so again, OB over AB is actually OB over AB equals to OE over AD. Okay, so the following relationship exists between the sides of those two similar triangles. OB over AB equals to DOE over AD. Okay, so what is OB? What is the size of OB? OB is the radius of the semicircle, and we also know that AO is also the radius of the semicircle because of the fact that it starts from the center of the semicircle and ends at point A, that is the point on the circle itself. So OA is also the radius of the semicircle, but OB is the radius of this semicircle, so OB equals to R. And what is the value of AB? The value of AB is R plus R. AB is the diameter of the semicircle, therefore AB equals to 2 times the radius of the semicircle. So AB equals to R plus R, that is to say AB equals to 2R equals to OE. What is the value of OE? OE will be remain as it is, OE over AD. What is the value of AD? AD equals to 7 units. It is given us in the question. So in total we got the equality that states that R over 2R equals to OE over 7. R over R is 1, so R is cancelled. So in total we will get here 1 over 2, because R over R equals to 1, equals to OE over 7. So here we got that 1 over 2, 1 over 2 equals to OE over 7. Again, from this equality we got that 1 over 2 equals to OE over 7. Here we will multiply this equality by 7, and we will get that OE equals to 7 over 2 units. OE equals to 7 over 2 units. Okay, the value of OE is 7 over 2 units. So we can write here that OE equals to 7 over 2. But what is the value of EC? What is the value of EC? EC will be equal to OC minus OE. Okay, EC equals to OC minus OE. Okay, EC equals to OE minus, again, EC equals to OC minus OE. Okay, EC equals to OC minus OE. But what is the value of OC? OC is the radius of the semicircle. So OC equals to R is the radius of the semicircle. And what is the value of OE? OE equals to 7 over 2. So in total we got that EC equals to R minus 7 over 2 units. So we can write here that EC equals to R minus 7 over 2 units. Okay, EC equals to R minus 7 over 2 units. And in the next step, actually we have here two right triangles, triangle OEB. This orange triangle is a right triangle because of the fact that it has angle of 90 degrees, therefore triangle OEB is a right triangle. And also triangle CEB, this triangle is also a right triangle because it has one angle that equals to 90 degrees. This is a right angle, therefore triangle CEB is also a right triangle. So we can implement the Pythagorean theorem on the two right triangles, and we can get the equality that states that EB squared equals to EB squared. EB squared equals to EB squared. Okay? EB square equals to EB square, and we created this equality because side EB belongs to triangle, the right triangle, triangle BOE, this triangle, and side OB belongs also to the right triangle, triangle BEC. So it is a common side, it belongs to both those two right triangles. Therefore, we will operate the Pythagorean theorem on this right triangle, triangle OEB, and then we relate to EB as it belongs to the other right triangle, triangle BEC. So EB square, if we relate to triangle OEB, EB square, if we relate to this right triangle, triangle OEB, will be equal to R square minus OE square. Again, EB square, if we relate to the right triangle, triangle OEB, will be equal to R square minus OE square. That is from one side, but OEB also belongs to this triangle, the right triangle BEC. Therefore, EB square, if we relate to this right triangle, will be equal to CB square minus EC square. So, in total, we granted this equality that states that R square minus OE square equals to CB square minus EC square. Okay, we related to EB that it belongs, we operated the Pythagorean theorem twice. One time we related to EB as it belongs to the right triangle, triangle EBC, and in the other time we related to side EB as it belongs to the right triangle, triangle OEB. Okay, and by operating the Pythagorean theorem twice, we got this equality. So what is the value of OE? We have already found out that the value of OE equals to 7 over 2. So OE square will be equal to 7 over 2 square. Equals to CB is 15 units. So CB square is 15 square. 15 square is 225 minus EC square. EC equals to R minus 7 over 2. So EC square will be equal to R minus 7 over 2 square. Okay, so in total, we got that R square minus 7 over 2 square equals to 225 minus R minus 7 over 2 square. Okay, so 7 over 2 square is 49 over 4, and here we will open the brackets, and we will get that R square minus 7 over 2 square is 49 over 4 equals to 225 minus R minus 7 over 2 square is R square plus 7 over 2 square is 49 over 4 minus 2 times R times 7 over 2. 2 times R times 7 over 2 So we found out that r minus 49 over 4 equals to 225. Here we have 2 in the numerator of this expression and we have 2 in the denominator of this expression, so we can cancel 2. We cancel 2, and what is left here is 7r, and we also will open the brackets here, and we will get that r squared minus 49 over 4 equals to 225 minus r squared minus 49 over 4 plus 7r. Okay, so in total we got this equality. Here we have minus 49 over 4 in this side of the equation, and we have minus 49 over 4 on the other side of the equality, so we can cancel minus 49 over 4. So here we will add r squared to this equality, and we will get that r squared plus r squared equals to 2r squared equals to 225 minus r squared plus r squared is 0 plus 7r. So in total we got this equality that states that 2r squared equals to 225 plus 7r. Here we will subtract 225 and also 7r from this equality, and we will get the quadratic equation of 2r squared minus 7r minus 225 equals to 0. So we got this quadratic equation, and the coefficients of this quadratic equation is actually a equals to 2, b equals to minus 7, and c equals to minus 225. Okay, and we have the general solution of any quadratic equation. If we have the general formula for a quadratic equation is actually a times x squared plus b times x plus c equals to 0 when capital A, capital B, and capital C are the coefficients of this quadratic equation, and x is the variable that we want to find out, and we will find out the variable by using a formula that states that x, so the solution to this quadratic equation is x equals to minus b plus minus root of b squared minus 4 times a times c over 2 times a. Okay, so that is actually the solution to this quadratic equation, but in our specific quadratic equation, we have 2r squared minus 7r minus 225 equals to 0. So if in the general formula for the quadratic equation the variable that we want to find out is x, so here the variable that we want to find out the value of it is r, so actually x equals to r. So we'll substitute x by r, and we will get that r equals to minus b equals to minus 7, so minus b is minus 7 is 7, plus minus root of b squared, b equals to minus 7, b squared is 49, minus 4 times a is 2, so 4 times a is minus 8, times c equals to minus 225, so it is minus 8 times minus 225, all divided by 2, times a, and a equals to 2, so 2 times a is 4, so we got that r equals to 7 plus minus root of uh, 8 times minus 8 times minus 225 is 800, is 1800, and 1800 plus 49 is 1849 over 4. So the radius of the semicircle equals to 7 plus minus root of 1949, and the root of 1949 is 43, so I write it down. So we will get that r equals to 7 plus minus 43 over 4. So we have one solution that r equals to 43 plus 7 is 50, and 50 over 4 is 12.5. We got one solution that states that r equals to 12.5 units. R equals to 12.5 units. But we should not forget the second solution that states that r also can be equal to 7 minus 43 over 4, and 7 minus 43 is minus 36, minus 36 over 4 is minus 9. So we got that the radius of the semicircle equals to minus 9, but because of the fact that the radius must be a positive number, So this answer is not possible, so we will cancel this possibility because the radius of the circle must be a positive number, and here we got that r is a negative number. So we left only with one solution, that r equals to 12.5 units. R equals to 12.5, and we know that the diameter of any circle is 2 times the radius. As you can see here, the diameter AB equals to r plus r. And actually the diameter is also equals to AB. So 2 times r is 2 times 12.5. 2 times 12.5 is 25 units. So we found out that the diameter of the semicircle, that is also equals to AB, equals to 25 units. Okay, we found out that the diameter of this semicircle equals to 25 units, and AB is equals to the diameter of this semicircle equals to 25 units. Okay, so that is the answer to the question. Now I will summarize the lecture. Actually, we wanted to find out the diameter of this semicircle, or to find out the value of AB, the size of AB, that is the diameter of this semicircle. And in order to find out the value of the diameter of this semicircle, we made a construction. We connected points D and B by a straight line, and then we defined the center of the semicircle as point O, and we also connected points O and C by a straight line, and we also connected points O and D by a straight line, and then we compared between the green triangle to the orange triangle. We focused on the green triangle and the orange triangle. We actually know before I continue, after we made the construction and we connected points D and B by a straight line, angle ADB, this angle is the right angle, according to the rule that peripheral angle resting on the diameter of the circle equals to 90 degrees. And this angle ADB, is a peripheral angle that rests on AB, that is the diameter of the semicircle. Therefore, according to rule number 1, angle ADB equals to 90 degrees. Okay, then we focus on the green triangle, triangle OCD, and on the orange triangle, triangle OCB. We know that DC equals to CB equals to 15 units. Okay, it is given us in the question. So DC in the green triangle equals to CB in the orange triangle. both of those two sides are equal to 15 units, and we know that OD equals to OB because OD and OB are the radiuses of this semicircle, so they are equal to each other. And also OC equals to OC, it is a common side, it belongs to the green triangle and it also belongs to the orange triangle. So we found out that all the sides of the orange triangle are equal to all the sides of the green triangle. Therefore, the orange triangle is congruent to the orange and the orange triangle is congruent to the green triangle according to side law, side rule, and therefore also angle DCO will be equal to angle BCO. Those two angles will be equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Okay? And we define this angle as alpha, so angle OCD equals to angle BCD. Both of those two angles are equal to alpha. And then we focus on triangle DCB. In triangle DCB, we know that DC equals to CB. It is given us in the question. Both those two sides are equal to 15 units. So DC equals to CB equals to 15 units. DC equals to CB equals to 15 units. And we have rule number 2 that states that in front of equal sides in the triangle, there are equal angles. So according to rule number 2, we have in front of this side, we have this angle, and in front of this side, we have this angle. So according to rule number 2, those two angles are also equal to each other. Therefore, angle EDC equals to angle EBC. Those two angles are equal to each other, and we defined one angle as theta, so the other angle must be also equal to theta. And then we focused on the two triangles, on triangle ECB and on triangle DEC, and on those two triangles we have side DC that of the green triangle equals to side BC of the orange triangle. Both of those two sides are equal to 15 units. EC equals to EC. It is a common side of those two triangles. And we also know that those two angles are also equal to each other, equal to alpha. Therefore, we found out that two sides of the green triangle, DEC, and the angle between them are equal to two sides and the angle between them of the orange triangle ECB. Okay, and therefore triangle DEC is congruent to triangle ECB. Triangle DEC is congruent to triangle ECB. Therefore, DE equals to EB according to the rule that corresponding sides in congruent triangles are equal to each other. So DE equals to EB, and also angle DEC this angle equals to angle BEC. Okay, angle DEC equals to angle BC. We define one angle is x, so the other angle must be also equal to x. So this angle is x and the other angle is also x. And we know that DB is a straight line because we actually connected points D and B by a straight line. And so along a straight line, if we focus at the certain point, then the sum of the angles on the one side of the straight line equals to 180 degrees. So if we focus at point E and at the straight line DB, then the sum of the angles on this side of the straight line must be equal to 180 degrees. Therefore, angle BEC plus angle DEC must be equal, those two angles, the sum of those two angles must be equal to 180 degrees, because of the fact that the sum of the angles at one side of a straight line at a certain point must be equal to 180 degrees. Therefore, angle BC plus angle DEC must be equal to 180 degrees. That is actually the value of angle DEB. Okay, so angle DEB plus angle BEC plus angle DEC must be equal to 180 degrees from one side, but from the other side we define this angle as x and this angle also x, so angle BEC must be also equal to x plus x, that is 2x. So from one side angle DEB must be equal to 180 degrees, but from the other side it also must be equal to 2x. So from this equality we can deduce, we can derive that 2x equals to 180 degrees. 2x equals to 180 degrees, and if we divide this equality by 2, we will get that x equals to 90 degrees. Okay, x equals to 90 degrees, that is to say angle CEB, this angle is 90 degrees, and also angle CED also equals to 90 degrees because it is x. Okay, so those two angles are equal to 90 degrees. And then we know that OC is the radius of the semicircle because it starts from the center of the semicircle and ends at point C. That is a point on the circle itself. Therefore, OC is the radius of the circle, and therefore it is actually also, of course, a straight line. So OC is a straight line. Therefore, we know that along a straight line at one side, the sum of its angles equals to 180 degrees. Therefore, this angle plus this angle must be equal to 180 degrees, because the sum of the angles along a straight line, OC is a straight line, at a certain point, point E, must be equal to 180 degrees. So angle CEB, that equals to 90 degrees, plus angle DBE must be equal to 180 degrees. So here we can subtract 90 degrees from this equality, and we get that angle DEB equals to 90 degrees. So angle DEB equals to 90 degrees. So this angle OEB, angle OEB equals to 90 degrees, because we added up those two angles, and this angle is already 90 degrees, so in total they must be equal to 180 degrees, and this angle is 90 degrees. So what is left here, that this angle also must be equal to 90 degrees in order to complete the sum of those two angles to 180 degrees. So angle OEB equals to 90 degrees. So this is also a right angle. Angle OEB equals to 90 degrees. So we actually found out that three angles around point E are right angles. This is a right angle, this is a right angle, and this is also a right angle. But we have the rule that around any point the sum of the angles is always equals to 360 degrees. So around point E the sum of the angles must be equal to 360 degrees. So we have already around point E three angles that equals to 90 degrees. That is to say, the sum of the angles, the sum of the three angles around point E equals to 270 degrees. So the fourth angle must be equal to 90 degrees in order to complete the sum of the angles around point E to 360 degrees. So this angle, angle DEO, must be equal also to 90 degrees, because 270 degrees plus this angle that equals to 90 degrees will be equal to 360 degrees. Therefore, angle OED also equals to 90 degrees. So we found out actually that all the four angles around point E are right angles. That is to say, they are equal to 90 degrees. Okay? And then we focused on two triangles. On the big triangle, triangle ADB, and on the small triangle, triangle OEB. So these two triangles, first of all, have one angle that is a right angle. So angle ADB that equals 90 degrees equals to angle OEB that also equals to 90 degrees. Then they have also a common angle. Angle B belongs to triangle OEB, and angle B also belongs to triangle ADB. Therefore, angle B equals to angle B. That is the second angle that is equal. So triangle ADB has two angles that equal, two angles of triangle ADB equals to two angles of the small triangle, triangle OEB. And according to the third rule theorem, the third angle, those two angles must be also equal to each other. According to third angle theorem, the third angle must be also equal to each other. So, because if we have two triangles that have two angles that are equal to each other, alpha equals to alpha and beta equals to beta, then the third angle is actually the total, the sum of the angles in any triangle is 180 degrees. So 180 degrees minus those two angles is the value of this angle. So the third angle in this triangle equals to 180 degrees minus alpha plus beta. And the third angle in this triangle will also be equal to 180 degrees minus alpha plus beta. So in this way we proved that if two angles in two triangles are equal to each other, the third angle must be also equal to each other. The third angle, this angle, also must be equal to this angle, because they have two angles that are equal to each other. Therefore also the third angle must be also equal to each other in both those triangles. the third pair of angles must be also equal to each other. So this angle also must be equal to this angle, and as you can see here, the size of the third angle is the same size in both triangles. 180 degrees minus alpha plus beta equals to 180 degrees minus alpha plus beta. Okay, so we proved that three angles on triangle ADB are equal to three angles on the small triangle OEB. Therefore, those two triangles are similar to each other, according to the rule of angle rule. If you prove that three angles in one triangle are equal to three angles of the other triangle, then those two triangles are similar to each other. Therefore, triangle ADB is similar to triangle EOB. And from this similarity, the following relationship exists between the sides of these two triangles. OB over AB equals to DE over AD. Again, OB over AB equals to OE over AD. Okay? But OB is the radius of the circle. OB is the radius of the circle, equals to R, and AB equals to 2R. R plus R is 2R. And we know that AD equals to 7 units. So in total we got that 1 over 2 equals to OE over 7. We multiplied this equality by 7. And we found out that OE equals to 7 over 2 units. But what is the value of EC? EC equals to OC minus OE. Again, EC equals to OC minus OE. And OC is the radius of the circle, and OE equals to 7 over 2 units. So in total, we got that EC equals to R minus 7 over 2. And then we actually have here two right triangles. Triangle CEB, this triangle is a right triangle because it has one angle that equals to 90 degrees, and also triangle OEB is a right triangle because it has one angle that equals to 90 degrees. Therefore, and we know that side EB belongs to this triangle, and it also belongs to this triangle. So we can implement the Pythagorean theorem twice. One time we relate to this right triangle, and the other time we relate to this right triangle. So we got the equality that states that EB square equals to EB square, and here we related to this triangle, and then the other EB square we related to this right triangle. So we got this equality. Here EB square equals to OB square minus OE square, and here the other EB square is we related to this triangle, that is actually equals to CB square minus EC square. Okay, and we got this equality, and after solving this equality we arrived to a quadratic equation. Quadratic equation 2r squared minus 7r minus 225 equals to 0. Here the coefficients of this quadratic equation is a equals to 2, b equals to minus 7, and c equals to minus 225. Okay, and then we have the formula to solve any quadratic equation. if this is the general formula for the quadratic equation, then this is the solution of this quadratic equation. But here we have r is the variable of this quadratic equation, so we substituted x by r, and b equals to minus 7, a equals to 2, and c equals to minus 225. So we put the data inside this equality, and we found out that the radius of the semicircle equals to 12.5 units. We have already the second solution, that the radius equals to minus 9 units, but it is impossible because the radius must be a positive number. Therefore, this possibility is cancelled, and we left only with the possibility that the radius of the semicircle equals to 12.5 units, and the diameter of the semicircle is 2 times the radius, that is actually also equals to AB. AB is the diameter of this semicircle, it equals to 2 times the radius. So r equals to 12.5, so 2 times r is 25 units. So we found out that the radius, the diameter of this semicircle equals to 25 units, or AB, that is the diameter of this semicircle that equals 2 times the radius of this semicircle equals to 25 units. Okay, thank you very much.